So hi dear students, welcome back to the next session on Rotary endodontics, and today I'm going to discuss a very important topic on Rotary endodontics, which is generations of night tie rotary systems, okay, night tie rotary files. And here I'm going to discuss with you different generations of rotary night tie files and how to differentiate between different generations first of all, then how to differentiate between different files, okay, and also you should be knowing the different cross sections, okay. There should be some knowledge about different cross sections of different file system. So I'll be giving you some tips and tricks of the different cross sections, and also how to remember some specific features of each and every system of files. Rather than just generations, you also need to know some details about the different file systems. And here I'm going to discuss with you some tips and tricks to remember, some mnemonics to remember them, and finally I'll be giving you an overview, okay. Initially I'll just give you a detailed understanding, because only and only if you understand these things systematically you'll be able to understand things out, okay. So as with all our lectures, we'll be starting with a systematic understanding of different generations, and then we'll go into the specific requirements, okay. So let us start. So basically there are 5 generations as of now. There are 5 generations of rotary file system, and we'll discuss what is the difference between each initially, okay. Then we'll go into the details. Now we know, we learned about the taper, we learned about the radial lands, okay, we learned about the rake angles. So if you have not gone through the previous lecture, go through that, then come to here, okay. I'll be giving you some idea, but still it's good to have a basic understanding of previous lecture if you have not gone through it, okay. So let's start with the first generation file system. Here the most important thing is that it had a radial land. So what does it mean to have a radial land? So like if you have like this, okay, this is that wide, this area is called the land, isn't it? We have studied this. If it is like this, it's a sharp kind of thing, it's non-radial land, or there is no radial land. And as you can understand, if you have a radial land like this, it's got less cutting efficiency, and if you have got like this, it's much more cutting efficiency, because naturally it's sharp, okay. Now that's very important. Now second feature of first generation, which differs from different generations, is that this people or this group of files had neutral or negative rake angle. And we have studied previously that if you have a neutral or negative rake angles, the cutting efficiency is again low. And if you have positive rake angle, you have got a better cutting efficiency, which is unlike the other restorative instruments. The endodontic instruments are slightly different. So we need to have a positive rake angle. The third thing which you have to remember here is they had a constant taper. When you go down, you will see that there is a variable taper, okay, and also you will see there is no radial land, the rake angle changes. So these are 3 very important features of the first generation system. Now you will come on to the second generation, okay, you will come on to the second generation, and it will become very easy for you to understand what is the difference. Exactly the opposite thing. That is, there was no radial land, so cutting efficiency increased, okay. There is no radial land. Most of them had positive rake angle, I'll just write it RA, okay, and mostly they had a variable taper, okay, variable taper, okay. We'll come on to more details as we discuss the different file system. Actually there are exceptions, okay. Now when you come on to the third system, the third rotary endodontics generation, third generation files, now it's completely different. Concept is changed completely. There is basically the same features of second is there. There is no radial land, there is positive rake angle, and also definitely cutting efficiency is more. But they've also added one more thing. They did something to the alloy. They they created a thermally treated alloy, okay. They created a thermally treated alloy, okay. This was manufactured, and different thermal treatments which were given were named as M wire, okay, M wire. Then we had CM wire control memory, okay, CM wire, So memory wire, control memory wire, and then we have R phase wires. Okay, so these are three different thermally treated wires. Okay, and basically you don't need to go into details of this. Basically what it did is it increased the elasticity or super elasticity, and it also increased the fatigue resistance. Okay, fatigue resistance, that means it didn't break as like the previous generation. So basically here what you have to know is the third generation had a thermally treated alloy, M wire, CM wire, R phase. Okay, so R phase we have already studied that there is a phase transformation into the twined martensite to the stressed martensite. You get what is the or deformed martensite, you get in between the R phase. I've explained this already in the previous lecture. Okay, now, so this is the third generation file system. Okay, then you have fourth generation. So first and second basically cutting and all those. Third, they mainly increase the elasticity and fatigue resistance. Now let us see what happens to the fourth generation, what they did with the fourth generation system basically. And what they did was, earlier it was a 360-degree rotation. The file simply rotated. Okay, sorry, it was in a clockwise manner. Okay, it's in a clockwise rotation. But till the first, second, and third generation, what happened here was the fourth generation had got a reciprocal. Okay, they had a reciprocal movement. Okay, I'll go into details when I discuss the system. So what it did is it had a clockwise to some extent, and then it returned to the counterclockwise like that. So reciprocal motion, so it gave some extra cleaning effect. Okay, and certain things I'll tell you this later on. Okay, basically not cleaning effect. Okay, it was less cleaning in fact, but the main thing it did was it decreased the torque. Okay, it decreased the frictional resistance, like more than 360 degree. It decreased the like if you are giving a 360-degree rotation, there is going to be more friction. So this decreased the friction and all. Okay, we'll come on to this details, what happened when reciprocal movements were generated. Okay, so that was the fourth generation. Again, nothing related to the system. It is just the reciprocal movements. Okay, now finally they came on to the fifth generation, which is the most recent generation, which you have to know, which is the most recent. And there what happened is they came up with irregular cross section. Okay, irregular cross section. Earlier we had different cross sections, like either it was triangular, S-shaped, you'll come on to details. Okay, or it had that convex triangular, all those cross section. But here you can't say a particular cross section here. It's an irregular cross section. Okay, you'll understand this in detail when you come on, but just now know that it is irregular cross section. So let's come on to the each generations one by one. So what did I say about the first generation system? The first generation system had a constant taper, isn't it? Constant taper, not variable taper. And then I said that there is a radial lant. So there is a radial lant, and there was a neutral or negative rake angle, which decrease, both of which decrease the cutting efficiency. Now very important is the examples, very important. Okay, and I'll tell you how to remember them. So the examples of this system is, I'll tell you this: profile. Okay, profile system. Okay, then endo sequence system. Endo sequence, just write it down. Okay, I'll tell you how to remember them. Okay, then we had the GT or greater taper. Okay, greater taper system. Okay, then we came up with Quantec. Okay, Quantec, there is a different system called Quantec LC and SC and all, but this is just Quantec. Okay, then we have light speed system, light speed. Okay, and don't worry, I'll tell you how to remember, and please take a note of this mnemonics or tips and tricks, whatever you can call it. Okay, now how to remember this is professional. Okay, professional, P for professional, endodontists. Okay, professional endodontics had greater, so just write it, had greater quantity of light in biological system, whatever you call it. I'll tell you what this biological system is. What is this biological system? In the root canal, isn't it? Root canal is a biological system. So for remembering purpose. So professional means profile. professional profile. Endodontist, endo sequence. Greater taper. Quantity, context. So you don't just remember this order. You know that professional endodontist will have a greater quantity of light in the root canal, isn't it? So just remembering it becomes easy. But remember, whenever you are taking down any short forms, you should be revising it prior to the day of exam. Otherwise, you will forget the short form, and what's the use of it then? Remembering things becomes very difficult. Okay, and you don't need to by heart them, you just need to revise them. Okay, because by hearting is not required. Basically, you have the options in front of you, so you just need to eliminate. Now, coming on to this is the best part of what you have when you're writing a BDS exam and compared to you're writing a NEET exam. Okay, NEET or INICET exam. And light is light speed and biological system is biorays. So if you know this much, it is good. Okay, so this is the first generation system which had a very little cutting efficiency because of radial lands present there and neutral or negative rake angle. So this is in general understanding. Okay, then we'll come on to the first system, light speed. So you can see there light and speed out there. So why is it called light speed? It's called light speed because they said that light touch is needed as speed of the instrument is high. Okay, only a light touch with the canal is needed because the speed is very high. You'll see that when we come down to the other system, the speed is much lower because here the speed is very high. And what's the speed? It's 1500 to 2000 rpm. If you have ever done your any root canal rotary endodontics, you'll see that it is much high, and due to this high speed, light touch with the canal was needed. Okay, and that's why it's called the light speed instrument. So same applies, or very similar concept is applied for the principal part. What is the principle being used in light speed? It is minimize as much as possible contact between instrument and dentine. What is that? Minimize the contact, as I told you. Okay, light touch. Okay, minimize the contact as much as possible. Okay, minimize contact as much as possible between the instrument and dentine. Okay, and that's why we are increasing the speed. Okay, instrument and dentine, so that you have very high speed, so you don't need to like press it onto the dentine, because this speed in itself is enough to get that much better cleaning efficiency. Okay, and basically you know that the cutting efficiency is much lower here. Okay, now when you come on to the tip part of this structure or of this file, it is non-cutting. And remember, okay, I'm not specifically mentioning in other cases, all are non-cutting tips. Okay, tips is different, cutting edge is different. If you take a file, okay, just a broad thing, this is the tip and this is here, you'll have the cutting edge, isn't it? This part is a cutting edge, so tip is here. So what I meant here is all the tips are non-cutting except in two cases. I'll tell you that. Okay, except in contact LC and in Pro Taper finishing files. Okay, we'll come on to that later. So all are non-cutting. All are non-cutting. If I don't specifically mention, it is all non-cutting, so I'm not mentioning it. And very interestingly, that the tip length is 0.25. So not tip diameter. Okay, not tip diameter, tip length. So how it is like this. Okay, you have some cutting edges here. Okay, just imagine, and rest is just nothing without any taper like this. Usually what kind of files you have? You have a taper like this and the entire 16 mm is cutting, isn't it? Here it's just 0.25 to 2 mm is cutting. Okay, so that's one typical difference here. Okay, only 0.25 to 2 mm is cutting, rest all is simply a straight thing. Okay, like the Gates Glidden file and all, if you have seen. Okay, so that's the tip and the cutting edge length. Okay, cutting edge length. So remember, it's very typical. We don't have, rest all files has got the cutting till the beginning of the shaft. Okay, here it is different. Now we're coming on to the cross section part. Okay, and remember, it is a triple U shaped with radial lines, and definitely yes, you know that there will be radial lines, but it is triple U shaped. Okay, triple U, it's first generation, so there will be radial line. Okay, triple U with radial line. Just write it down because sometimes exceptions can come with radial line. What is this? Okay, this is triple U, that is 1U, 3 U's, isn't it? So they can give you either of this image. So this is 1 U, okay, 3 U's. Okay, so this is the radial land I was talking about. This is the radial land, which makes it a kind of non-cutting. Okay, so the cross section, first file system we studied, the first file system cross section is triple U shaped with radial lands. Okay, remember, don't forget. Now we come on to the next file system, which is profile. Again, there is no doubt it is constant taper we studied. Okay, and very importantly, you have to know that I told you some specific features for some specific instruments, and we have it here. It's called series 29 instruments. Okay, series 29 instruments. Okay, what is the series 29 instruments? That is, these instruments had a constant proportion of diameter increment of 29%. What? There is a constant proportion, okay, of diameter increment of 29%. Diameter increment of 29%. What does it mean is, you have the tip diameter between two instruments. So one instrument is like this. Just imagine this is one instrument and this is the second instrument. So the tip diameter increase. So this is the tip diameter, isn't it? This is the tip diameter. This is the tip diameter. So the tip diameter increases 29% from the previous instrument. So the next will have more, 29% more, like that. It's a 29% increase between different files in the tip diameter, which is not the one which we see in the conventional files. So it's a series 29 instruments, and remember, I'm not going to discuss all the tapers of all the instruments. Okay, very specifically I'll mention. So series 29 had got a 2% taper. So remembering is easy, 29 and 2. Okay, 2% taper. Okay, so that's about the profile system. Very, very important profile system. What you have to know is, that is, they have got a series 29 instruments. Okay, series 29 instruments. So other name, you can call it as other name also. Okay, so because constant proportion of diameter increments. Okay, now coming on to the cross section part. Again, it's the same cross section like the one we saw in the light speed. Okay, it is triple U. Okay, triple U shaped cross section with radial lines. Okay, with the radial lines, triple U with radial lines, same like the previous one. There was no difference to be noticed here. Okay, triple U shaped cross section. And then you have to know is, again, the same thing, neutral or negative rake angle, or neutral or negative rake angle, which is specific for the instruments which is having the first generation, okay, which are coming under the first generation. So two things, again, the cross section doesn't change, triple U, but only thing which you have to remember is, in profile is it is a series 29. The cross section is not changing, it is triple U with radial line. It is going to get complicated, so let's wait for that. Now another thing which you have to note here is speed. We said light speed is how much? 1500 to 2000 RPM. Here, that's why I'm saying it was too high. It is 150 to 300 RPM, very less, isn't it? And this is the normal one which we have. So that was very high speed, isn't it? And into this profile system, which we'll study in later on in Vortex, okay, a recent addition is there, which is called the Vortex system. And so it's a modification. This Vortex is a modification of profile. Okay, so professional. Okay, professional. So order is not being maintained, isn't it? Professional, endodontist and all. But remember, profile is a first generation system, and its recent modification is called Vortex. And what they have done is, there is no radial land. So no radial land cross section. Okay, cross section and M-wire technology, and that's why they come under the later generations. Okay, M-wire technology. I said thermally treated, fourth generation, isn't it? So it's M-wire technology, Vortex. So Vortex is a modification of profile system. Okay, so that's a second system. So first we studied light speed, then we studied profile. Now we're going to see, so profile series 29. That's the most important thing which you have to remember, series 29. Now greater taper. I don't know why they kept the name greater taper, but probably could be there is more taper system coming. So I'm not discussing any tapers here. Just to know, there was additional tapers added. They had 6, 8, 10, 12 tapers. Earlier instruments, light speed, no taper at all. Then came the profile system with 2, 4, 6, and 2 was the series 29. So now there are more tapers. So that's why, that could be probably the reason they're saying that it is 4 or there was greater taper is there, or GT file, and profile GT, so they combine the name profile GT. Okay, now very important point to remember here is it's a variable pitch. Okay, it's a variable pitch, and you know what is pitch. I'm not describing it again. I've described this in the other lecture. Okay, again the cross section is going to be the same, which is triple U. So the first three, very simple, it is triple U. Okay, triple U shape cross section with radial land, and here the recommended speed is slightly higher, 300 rpm. Okay, other one was 150 to 300, isn't it? The profile was 150 to 300, now it's 300 rpm. Importantly, it's variable pitch. Okay, variable pitch cross section is going to the same. So we studied three sets of instruments so far. What was they? One was light speed, nothing much there. Okay, then we studied the profile, which is series 29, and then greater taper instrument, which is variable pitch. All the three had the same cross section of triple U shaped cross section. Okay, so that's about the first three instruments. Now let us go on to the next one, which is endo sequence. Okay, endo sequence. Now you could see ACP there. That's the most important feature, endo sequence. So I'll just connect them. Here it is triangular cross section. So the cross section changed now. Okay, triangular cross section. Remember, so till now we had triple U. So endo sequence changed triangular cross section. Okay, and then you have another very important feature, which is ACP. What is ACP? Alternating wall contact points. I'll tell you this. Okay, contact points. What is that? Alternating wall contact points means, just see this picture. So this is a file, you can see here, this is a file system, and if you see the file system, there is three contact points here first, then becomes one contact point, then there is one area with two contact points, like that, then there is no contact point, zero contact point area, like that. It's not like normal files where there is regular contact points. If it is three, regularly three, but here it is changing. Okay, it's three, then two, then one, so different. So in this area there is three, then you have two here, then you have one here, there is nothing here. So that is what is alternating wall contact points. So different wall having a different contact points, that is what alternating wall contact points. Now what is the purpose of this? Now we want to prevent the breakage of the file, and this does it. That is, this reduces or this decreases the torque. Okay, this decreases the torque and keep the file centered in the canal. So like it prevents the breakage. Okay, it prevents the breakage, so it's very important. And now the speed is slightly higher in this case. This is 600 rpm. Why is it 600 rpm? Here actually they smoothened the surface. Okay, they electrochemically treated it and they smoothened the surface, and so again smooth surface means less friction. Okay, so I'll just write it down. So they did is electrochemically treated it, okay, the file after manufacturing, so it becomes more smooth, so less friction, so they can use a larger speed because it won't break. So remember the fourth system, endo sequence, and the most important thing here is ACP, alternating wall contact points. So we studied light speed, we studied profile, which is series 29, then we studied the GT, greater taper, which is variable pitch, and now endo sequence, which is alternating wall contact points, endo sequence. So see here, there is something called a sequence. What is the sequence? Sequence of contact points, just to connect it. Okay, nothing related, but endo sequence and ACP, so they are connected, isn't it? So alternating wall contact points. So that's all of the first generation system. And in the first generation system, I'll just tell you once again, one was light speed, okay, which was zero taper instruments, high speed was used. Then we had the second group of file, which was that profile series 29. Then we had greater taper, which was variable pitch, and then we came last one, endo sequence. Okay, endo sequence, which is the sequence means it is ACP, alternating wall contact points. Now coming on to the second generation, I told you that is there is no radial lands, so better cutting efficiency, positive rake angles, okay, and variable taper or progressive taper. So the first example of that itself is pro taper, so that's why it's called progressive taper, pro taper and pro taper U. I'll tell you how to remember this. Okay, pro taper U, you know it. Okay, you know them. Pro taper and pro taper U is the most commonly used. Okay, U is universal. Okay, then you have M2 K3, S5, okay, S5, BioRace, FlexMaster. I'll tell you how to remember them, don't worry. FlexMaster, Quantec, SCLX, and Hero. Now here, if I put a mnemonics here, it's going to be in trouble. So second generation is not based on mnemonics, it's based on some, you can call it as memory palace or whatever. One thing you can easily remember, Pro Taper and Pro Taper Universal, second generation. Okay, you've been using it. Okay, you have been hearing it at least. So it's one of the most commonly used. Now things are changing, but still it's the most commonly used one. Now then there are numbers M2, K3, S5, like that, isn't it? So these are numbers M2, K3, S5. So it's like three cards being set there for a race. Okay, bio race. So three cards with three different numbers being kept for a race. Okay, and there is one master. Okay, and there is one hero, isn't it? For looking after the race, there is a hero who is the driver, and there is a master who is looking after the race. Okay, and Contact LC, which is the name of the stadium, Contact LC Stadium. Okay, Contact SCLX, sorry, SC or LX. There's two different systems. So remember Pro Taper and Pro Taper U. Then it's easy. M2, K3, all the numbers. So numbers of the cards where the race is going on. Bio race. Now here there's a small problem. That is, bio race is being included. Bio race. Later on it became BT race, okay, BT race system, okay, booster tip race, okay. So this is actually the second generation system. The actual BioRace is first generation only, but in different books they have even added BioRace in second generation. So remember, try to remember it's BioRace in the biologically, it's BioRace, and here it is race, basically BT race, okay, remember like that. Then a master, Quantec SC, hero, okay. So we'll come on to the first system here. Okay, one more thing I just want to tell you here is, we said second generation mostly had no radial lens, but there is one exception. There was wide radial land. Okay, there is the K3, which is wide radial lens. Okay, which means the cutting efficiency is lower. Okay, and then we said in the second generation there is a positive rake angle, but in hero you had a slightly negative rake angle. So just remember the hero, though he is hero, he has got some negativity, isn't it? Because basically it's a car racing, and at the end of the car racing, you know that they take photos with some girls, isn't it? So there is some negativity in this person's hero. Okay, it's negative rake angle. So then you come on to the first system of this rotary files, which is K3 files. Okay, K3. So numbers, basically I said you it's numbers. Now just know, I've just mentioned the name. It was given by Max Payden. Just to know, I'm not giving the names of all, but by Max Payden. Okay, John Max Payden. Okay, John Max Payden. Okay, this person. What he did was, initially he developed a system of files called Contact, which is first generation. Told you, isn't it? Contact. No, Contact is second generation only, isn't it? This is a confusion which happens. So Contact 2000. Then he come up with Contact SC, Contact SC. Okay, then he come up with Contact LX. Then finally he improved this one, LX into K3. So finally this is how K3 came. Okay, so Contact 2000, then SC, then LX. Now the difference is, I'll explain this to you. Okay, here in the Contact system, if you take, it is basically both of them is composed of, all the three is composed of two radial lands. You know what is radial lands now? Okay, two radial lands. But when you come on to this one, you have three radial lands. I'll show you this. Okay, three radial lands. Okay, three radial lands. And I told you all are having non-cutting tip, except I told you two. So of that, one is this. Okay, this is the only file system other than the one which I'm going to explain later on, which has got a cutting tip. Okay, cutting tip. All others, if they ask you, they have got a non-cutting tip. I'm talking about tip, not cutting edge. Okay, so the difference is majorly here is two radial lands and three radial lands here. So this is the first system. So I'm keeping aside the first generation. Now I will be discussing about the second generation. So it's K3 files, three radial lands And basically this file system is considered to be a system which is transition from the first to second. Remember, I told you there is a exception, that is K3 has got a radial land. So these people have got a radial land, okay, though it's in the second generation, they had a radial land, considered to be having radial lands, but the cutting efficiency was due to positive rake angle. Okay, rake angle. Remember I told you about the exception, which is K3, isn't it? K3. Yeah, this is wide radial lands, and which is 3 radial lands. Contact also 2 radial lands. So it's a kind of transition, isn't it? From first to second, because first had radial lands, this also had a radial land, but first generation had a negative rake angle, this have a positive rake angle. Now the speciality, like the profile system is said about series 29 instruments, here it is something called as axis handle. Okay, axis handle. Now you're not going to details about this axis handle system and all, but remember that due to this axis handle, the shaft or the entire file system can be made 4 mm shorter than the other file. Okay, other files you can make it 4 mm shorter, okay, so that it gets much more control because of this axis handle system, 4 mm shorter than the other file. So which one has axis handles? K3 files. Okay, K3 files has got axis handle with radial lines. Now this is what I'm going to discuss. Now I told you two things here. It had radial lands, isn't it? I told you that they have got a radial land. Okay, there is a radial land, but there is a reduced radial land. Unlike the other instruments which first generation had, there is a reduced radial land, and there isn't this thing. See this area, there is a radial land relief. Okay, there is a relief area, so that friction decreases. Both of this purpose is to decrease the friction. It is because contact decreases, isn't it? So there is a relief for two of them, not both. Okay, so one relief is here, one relief is here, one relief is here. See here, there is no relief, there is only radial land, there is no relief. So out of the 3 radial lands I was talking about, 2 of them were given a relief, one was not having the relief. And the second thing which I've told you is a positive rake angle. See this is the rake angle positivity. Okay, so remember K3, lots of things to know. Okay, one is its evolution from contact to K3, so thus having 3 radial lands, remember, and it's a transition, so it's a positive rake angle with radial lands. Okay, and remember this axis handle. Okay, so we have done the first instrument in second generation, which is K3. Now we'll come on to the second instrument in the second generation, which is ProTaper and ProTaper Universal. ProTaper and ProTaper Universal. Now this was designed by, now ProTaper is very important one. So you have to know the name of the person who designed it. The name of the person who designed it is Cliff. The 3 people: Cliff Rudel, okay, Cliff Rudel, John West, okay, John West, and Pierre Machto. Okay, Pierre Machto. So these are the designers, okay, Cliff Rudel, John West, and Pierre Machto. So this is very important. Now we'll come on to the cross section. So remember the first generation, just go and revise the first generation and come back. Okay, first generation cross section, if you revise now, it will become easy. I'm not going to repeat it again and again. Okay, it's easy. So now the cross section of second. Now about the K3 system, they are not explaining much about the cross section, but into ProTaper they are saying about 2 cross sections. Okay, and mainly it is a kind of modified K file. Okay, they're saying that the cross section is like a modified K file. You know, the K file having a square cross section, or it can be having a triangular cross section. So though I know that you have studied it is square, but remember K file and reamer can be designed both square and triangle. Okay, it can be designed as both square and triangle, but K is much more designed to be square and reamer is much more into the triangle cross section, but it can be done as both. Okay, if you go into depth of the standard textbook, you'll see this. So it's a modified K file with a convex triangular cross section. Okay, convex triangular cross section, and there is no radial land. Understandable. See this is the no radial line, isn't it? So this is the no radial line, and convex triangular, isn't it? Convex nature. But you know, if you go on to the the different system of file system. There is shaping files and finishing files. So finishing files are F1, F2, F3, F4, F5. So of which F3, F4 and F5 has got a U-shaped cross section. Remember this, okay? It's got a U-shaped cross section. So don't forget. It's normally it is convex triangular, but F3, F4, F5 is U-shaped cross section, and it has got. Now let us come on to the file system, and I've told you it's a variable taper or it's a progressive taper. That's why the name is pro taper. Okay, now remember, these were the first set of instruments to show different conicities. I'll explain this. Okay, different conicities along the shaft of the instrument, along the shaft. So just finish off this lecture, okay, because it's very important. In one instrument, so in one instrument there was different cones, different set of cones. That means it is basically saying that it's a progressive taper. Okay, we'll understand this, but they can ask you question like this. Okay, the first set of instrument to show different conicities along the same instrument, different conicities along the shaft. Okay, so that's the pro taper U. Okay, we are discussing both together. Now we have shaping files and finishing files in ProTaper. If you have used it, you'll see that its shaping file is there, shaping the canal and finishing the apex. Okay, finishing is basically to the apex part. So shaping file, it is SX, S1, S2, that is S for shaping, and the finishing was F1, F2, F3, F4, F5. Okay, so let us discuss them separately. Now when you come on to the shaping file SX, it was an orifice shaper. Okay, the orifice, the entry point, isn't it? The entry point shaper, that is orifice shaper. So it's an orifice shaper file. Orifice, okay. I'll tell you the different uses. Okay, orifice shaper, the SXs, and this is the purpose, the action is orifice shaper means its action is same as Gates Glidden. Okay, Gates Glidden file, and they had this file system as a whole had an identification ring, but SX no identification ring. So this can be a question. The Pro Taper system with no identification ring is SX, rest all had it. Okay, now second is about the second system, which is S1, which is second shaping file. So I told you it's used for, the first one is used as orifice shaper. This is used for shaping the coronal part of the canal. Okay, coronal part of the canal. This one is orifice, this is coronal part. Okay, you know orifice is the opening, this is the coronal part, and I told you there is no identification ring in SX, but this has got a purple identification ring, like the file 10 we call it. Okay, it's completely different, not related, but like the file 10, it's purple. Okay, then the diameter is different. Okay, then you come on to the S2, which is to prepare the middle third. So apical third, we use what? We use the finishing files, and the middle third we are using the S2, and it has got a white identification ring. So it's not much problematic, I'm not going to detail, but one thing which you have to remember is this shaping file is having a partially active tip. I told you two tips are active. One was contact SC, and this is shaping file of ProTaper, only shaping, not finishing. Okay, so the partially active tips, and remember it, the taper increases coronally. And when I'll tell you this, why I'm saying this, okay, increases coronally. When you come on to the finishing files, the taper decreases coronally. So remember this, the taper increases. So this is normal. In most of the files, taper increases, or most of these set of files, the stop taper increases coronally. But when you come on to finishing files, you see that taper decreases coronally. Now, the same shaping files, I want you to learn two things here. One is tip diameter, and second is apical taper, the taper at the apex. Okay, apical taper, because this has got a progressive taper. You can't say that it has the same taper is there throughout. No, it's progressive. So it's better to learn the apical taper only. And as I told you, the taper increases towards the coronal part. Okay, so SX, the tip diameter is 0.19 mm. Okay, tip diameter is in mm, 0.19, then it decreases 0.17, then it again increases, so 0.19, 0.17, 0.20. Okay, so then you come on to, okay, before that, the taper part. They are not explaining the SX taper, but this one is 2% taper. So how you write 2% taper? 0.02, 0.04, or you can call it as 2% taper or 4% taper. So remember this, okay? 0.19 decreasing, 0.17, because this is orifice taper, it should be bigger, isn't it? Orifice, then it has to be decreased, 0.17, 0.20. Now the same 0.20, when you come on to the finishing file, you have the same 0.20 here, okay, 0.20. And there has been a question which the Pro Taper system having the same tip diameter, S2 and F1, okay, same one, okay, then it is very simple. Okay, then it's very simple, 0.20, 0.25, okay, then 0.30, 0.40, like our normal file system, 0.50, 30, 40, 50. So it's 0.19, 0.17, 0.20, then 0.20, 0.25. So that's 5 difference, then 30, 40, 50. Okay, then the apical taper, not tip, apical taper, it is, we studied it is 2 and 4%. So the same 4% is here, 0.04. Okay, but it is different here. It is 0.07, 0.08, 0.09. So don't forget this, 0.05. So that is decreasing, because larger diameter file you have to decrease it, otherwise it's too huge taper. So remember the taper here, okay, don't forget, it's 0.02, 2%, 4%, then it becomes 7, 8, 9, then 5, 4. So these two are same, isn't it? 4, 4. So the ends are the same, and in between you have 0.2%, then you have got 7, 8, 9, then again coming back 5, 4. Okay, so that's about the taper of the instruments. Now problem solving. There has been a question asking you that if you take quickly, I'll just tell this. If you take an F2 file and you cut 1 mm, what is the new tip diameter? What's the new tip diameter? So you're taking the F2 file. So what is F2 file? F2 is, what is the tip diameter of F2 file? Normally it is 0.25. You are cutting 1 mm. That means you are increasing the, you are going to the next 1 mm. There will be an increased taper of 0.08. Okay, so that is plus 0.08, which will be 0.33. So the new tip diameter is 0.33 mm. So this can be done with any one. If you're taking this one, F3, it's 0.3 plus 0.09. So if you're cutting 2 mm, so 0.33 plus 0.09 plus 0.09. It's simple, okay? Now, just to come to this part, okay, before that, you have to know two very important points about the Pro Taper finishing files. It is non-cutting tip. Okay, we said that the shapers are partially cutting, and the taper decreases coronally. We said, okay, we said that when we come on to the shaper files, it increases coronally, but here in this case, it decreases coronally. How it is? Let us see. Here the taper is 2%, 4%, and it is increasing 11, 11.5. That is shaping. But when you come on to the finishing files, it is 7, 8, 9, I've told you. And see, this is decreasing, it's 5.5, from 7 to 5.5, from 8 to 5.5. From 9 to 5, it is decreasing, whereas this one is increasing. You don't need to learn the taper, but you know that the shaping files are increasing coronally, this is decreasing coronally. Okay, so that's the difference between two different shaping files. Okay, sorry, the two different set of files. The speed is 250 to 300 rpm, so it's easy to remember, 300 rpm. Okay, 250 to 300 rpm. And some textbooks, or the Cohen in fact, says that there are two usage characteristics for Pro Taper files. One is, that is, before using it, you should be knowing two things. One is, there should be a glide path for its passage. Okay, there should be a gliding path, something to guide, isn't a glide path. I'm not going to detail of glide path at all. Remember, it needs a glide path, and the usage, the working stroke is lateral brushing. Okay, lateral brushing stroke. Okay, lateral brushing, the working laterally, just press laterally onto the canal so that it is not threading onto the canal, decreases friction, doesn't fracture. But remember, it is basically lateral brushing force. Those two systems we studied in the second generation. One is K3 and the second is the Pro Taper. K3, I've told you, one is its generation 3 radial lines but positive rake angle axis handle. Okay, K3. Pro taper, very simple. Two cross sections, one is convex triangular, and F3, F4, F5 has got a U-shaped cross section with a radial lant a little bit, isn't it? But not mentioning. Anyway, different conicities and all those. So remember the taper 2, 4, okay, then 7, 8, 9, 5, 4, okay, and problem solving done. Okay. So that is about the second generation. Now we'll come on to the third set of file of second generation, which is FlexMaster. Okay, that I'll discuss in the next session. Okay, I'll discuss them in the next session.